Hello again and welcome. Today we're going to start looking at the Keysight U1282A. If you're not aware, I ran a poll when we approached 20,000 followers, and this was the meter that people voted most popular to see. Now, of course, this meter's been around for a long time. Dave at EEVBLOG had done some pretty extensive testing with it. I think this is the one he took up into the mountains and swam with or something. There's some other members on the EEVBLOG that have also done reviews on this meter. As a matter of fact, I made a video where I went through the front end design of it and we tested it. I'll provide some links to those videos in the description if you're interested. So here you go. This is what it comes with. Here we have the certificate of calibration. The date on this is the 24th of December 2021. Let's see. Thank you for selecting Keysight Technology products. This was supplied with, of course, the meter, true RMS, 60,000 count, handheld DMM with option core, W4100A-3MW, ABA, BL1, UK6. Comes with a calibration certification, standard accessory kit, IR cable for the USB. Of course, it comes with a warranty, 3-month for included accessories, product supplementary sheet, and finally the commercial calibration certificate with test data. Looks like for calibration they used the Fluke 5522A. It's interesting, they also used a 33522B function arbitrary waveform generator. Here we have the IR cable. It's nice they supplied that. Of course, this meter is quite expensive. Probes look fine. And we can assume this isn't going to power up. I mean, compared to this, I like the nice click. This is harder to turn, and it feels quite mushy. I don't know. To each their own. Of course, everybody's going to have their own preference when it comes to the range selection switch. Let's go ahead and we'll just pop this cover off. Here we can see the separate fuse holders. Nice rubber gasket here. You can see it's using SEBA fuses. One at 440 mils and the other one is at 11 amps. Just the idea is that you're only going to be lifting one side or the other, so it's hinged in the center. And we'll just install the supplied batteries. These are a Maxell part. Doesn't look like anything's been leaking. I think we're okay to go ahead and install these. And let's see if it'll turn on. Tell you what, let's just pop the back cover back on this and we'll run through a quick functional test. The case itself feels pretty rugged. I have no doubt that mechanically this thing is going to be quite robust. Of course, I'm going to hold my judgment about the knob. The last Keysight meter I looked at, you may remember that they had used a glass-filled detent spring, and that spring broke after just a few thousand cycles, basically bringing it back and forth like this, and it broke all 4 tangs of the spring. What we'll probably do is take this switch apart before I actually start cycling it, and we'll just take a look at what materials were used. This is the Fluke 189. Okay. This is the Bryman BM 869. Harder to turn, huh? Okay, between these two, which one would you pick? Really? Most people would go with this. People like that feel. And if you do it with this one, this is the 189. Very similar, huh? Alright, so this is Bryman's new meter, the 789. So between these two, what do you think? Huh? Alright, let me know what you think of this thing. She's nodding her head no.
It doesn't have a precise...
Yeah, that's what, it's very spongy, isn't it? Like,
Yes.
you could just see it right there, how much you can move it before finally clicks over, sorta, kinda.
And see, the fluke actually felt that way on some of the movements.
Well, let's be fair, this is like a 30-year-old meter.
Okay, that
right?
That one has slop in it. This one still snaps right where it's supposed to.
I mean, if we try Frankie's meter, that's had a lot of use on it.
Yeah.
But again, very old, you know?
This feels like turning on the dial on the oven and trying to get it at exactly 350. It's kind of like...
This is the Unity meter that we bought last time. What do you think of that?
Besides the annoying beep. That one has slush in it too.
It does. It's not as tight.
Right.
If you had to rank it between these two, which one would you go with? Really?
Yeah. Yeah. This one just feels I feel like I have to be very cautious to get it exactly where I want it to.
Alright. Try this one in between. See what you think.
It moves very easy, but it hooks exactly where it's supposed to.
So out of these two, which one? Keeping in mind, it's like a, now I think that's like a $900 meter. Maybe over 900.
Well, I have good taste.
Versus $230.
You know, what's interesting is that this one I can push, like, I have to, it moves easily, but it snaps in, but it would make it so I could move it too fast.
Alright,
another fluke.
This is the gold standard, I understand, of meters. Fluke 87V.
Oh yeah, the one that died early.
Not that one.
No, but your first one.
Yes.
Here's what's interesting is that this one has so much less.
Mm-hmm.
You have to push it further.
Yep.
in
Compared to
between
that, there's a lot
Okay.
more functions on there.
Yeah.
Yep.
As well as there's more functions on these two also.
So between these two,
This one.
Fluke.
Yeah. Yeah.
Well, there you have it. My wife, who's never turned a meter selector switch in her life, not liking the Keysight.
And you can't use that.
That's interesting. You see, I don't like it either. You know?
It's,
It's just mushy,
yeah.
you know? This is the Yokogawa. Nice Japanese switch. See what you think of that. Yeah. Actually, I like the feel on this one.
Mm-hmm.
It's very, very easy to rotate. Clicks right into place.
Yep.
Yeah.
It's a good one.
It's too bad the meter's got other issues, but
It's got a cool name though.
Yep.
Yokogawa.
they're well known. Okay, you're out the way.
Okay. Come on, Doc, let's go. In circles. Come on.
Time is greatly appreciated.
Okay.
And we'll be using our test box here. Let's just start with our AC volts. This is going to be 2.5 volts. Looks good. Let's see if it can read frequency. Should be 60 hertz. You can see it's spot on. It should also be 60 hertz. It's nice. It's got the twin display. You can see it's 2.4892, and again it's at 60 hertz roughly. This should be 30 hertz, and this is 15 and 120. Looks good. This should give us roughly 70 volts. You can see it's 66. It's fine. And roughly 3.2 kilohertz. That's correct. Let's try changing over to DC. Same waveform. This should give us roughly 60 volts. And we can see it's roughly 57.7. And let's just change over to AC plus DC. This should be roughly 90 volts. And we can see it's reading 87.4 or so. That looks fine. And now let's select AC millivolts, and this should be roughly 115. Looks good. 118. Kind of annoying. Let's see, this should be 100 microamps. Looks really good. This will be 10 microamps. That's fine. 1 microamp. That looks good. And 100 nanoamps. It's a little off, but not a problem. And of course, let's go to amps. And again, this will be 100 microamps. Does it read? One place, it does. Okay. So that all seems like it's working. Let's try going to... That is just really annoying. Let's try going to temperature. This should be about 24 degrees Celsius. This should be 1040. In the center here, this should be around 500. That looks good. Let's just check the millivolt reading real quick. Yep, that looks fine, about 20 millivolts. Let's try resistance, and this is going to be a 0.5 ohm. Let's just try zeroing it out. Yeah. Okay, here's our 0.5 again. Fairly close. This will be a 1 ohm 1%. Let's just check our offset one more time. Looks fine. Again, 1 ohm 1%. This will be a 50 ohm 0.01%. 100 ohm 0.01%. You can see it's kind of slow for the auto range. You'll be waiting a while to take measurements with this meter. This will be a 1K 0.1%, a 10K 1%, a 100K 0.1%, one mega ohm 1%, 10 mega ohms 0.1%, this is a 40 mega ohm 2%. It's a 100 mega ohm 5%. And here we have a 1 giga ohm 5%. Let's see if it'll read conductance. Okay, it doesn't look like it supports conductance. I have a hard time believing this meter can't make that measurement. Alright, let's go to diode check mode. Again, here's with a short. And here is a single silicon diode. And here's 2 in series. That looks fine. Let's just try our white LED. Oh, it looks good. It can measure it. It's certainly lighting it up. I think you can see that down here. I don't know why that's a big deal for people, but apparently it is. Almost forgot. I should probably check the DC voltage here. This will be 5 volts even. Huh. Takes a long time for this to settle. Let's just piggyback our BM869S. And again, we'll place it to DC volts as well. And now let's turn on the output. Looks like our Keysight's reading a little on the low side. Here it is against one of the Fluke 189s. Yeah, I'm saying this Keysight meter reads a little on the low side. Again, surprising that it's that far out. Alright, let's go to capacitance. Let's see about zeroing this thing out. So we'll hit the null. And again, here's the 150. It looks good. Here's a 0.1 microfarad. Really good. And 1 nanofarad. Looks good. We have 1 microfarad. Really good. And 10 microfarads. Looks good. And 100 microfarads. Again, it's very slow, but it does seem to work. Let's try this frequency mode. This is switching at 60 Hertz. Of course, this is capacitively coupled. And let's try it with our DC offset. Oh, again, it's so slow, you really have to wait for it. So again, this is switching between 0 volts and 5 volts. So it looks like the meter wants the 0 crossing for this thing to pick it up. Let's try it at 30 Hertz. Yep, can't read it. 15, can't read it. So again, to measure the frequency, we'd have to select either the AC volt mode, or I'm sure millivolts can read it as well. Let's just try that. Yep, no problems at all. Here we are at 120 again. Yep, no problem. 30 Hertz. And let's just try the continuity test. It's nice, you get the little V-Sense light up here. Looks fairly fast. Let's have a look at our backlight. Has a nice Keysight orange glow to it. The display itself looks pretty sharp. Let's go ahead and take our screensaver off. There you go. Alright, I downloaded the manuals for the Keysight meter. Turns out it does support conductance. We have to manually range the meter to get it into that mode. So I was looking for something screen printed onto the function switch like the Brahmin here. You can see nano Siemens. Same thing with the 189. Of course, this Keysight, we don't see anything like that. But if we just go to range, and there you can see nano Siemens. So let's have a look now. Again, this will be our 100 mega ohm. This should read roughly 10 nano Siemens. There you go, it looks good. Let's just try it with our giga ohm. This will be 1 nano Siemens. Looks like 1.02. Looks pretty good. So the other thing I did was I looked up this frequency counter mode. Looks like the manual says that this is for low voltage measurements. So while I think that this would be made for looking at digital signals, again, attaching it to our test box here. So again, here we're switching between plus or minus 2.5 volts. And you can see we're reading 60 Hertz. But here, I'm switching between ground and 5 volts. And it takes a long time for this thing to update, but there you go. So while I think that you'd be using this to look at 0 to 5 volt signals, it needs that 0 cross to fall below ground in order for it to pick this up. Now they claim that this is good for 100 megahertz. This is with 1 megahertz applied, and you can see it's reading 1.005. Let's just go ahead and turn that up a little bit. And there you have 2 megahertz. Let's double it again. It should be 4 megahertz. Wow. Alright, let's see where it gives up at. Again, to be clear, I'm putting out about 22, maybe 23 dBm into the meter right now. Looks like 2 megahertz it rolls over. Wonder if there's a... Oh, here we go. So you have to select the range selection. You can't just auto range it. And here you go. So 2.47. I'd buy that. Yep, 2.4798 is what we've got on the generator. Same with what's on the meter, so spot on. This would be 4 megahertz. So we are 8, 16. It should be 32. Let's try the range select again. Nope. Looks like it's having a problem picking this up. So this is 25.9, and you can see it's reading 64. Right there it switched. Yeah, it's reading roughly 25.471 or so. So the meter seems to be accurate enough. It's just having a problem. My guess is we need more power applied to the meter. Of course, with this being a low voltage input, you may remember that's how I smoked that Unity meter. I think they claimed 200 megahertz on that particular meter. Of course, we hooked it up to a power amplifier and I smoked the front end on that. That particular meter, I used 2 PTCs in series instead of having a surge rated resistor. And of course, those PTCs act like a capacitor. At the higher frequencies, they basically become a dead short. So we shun all that current right through those PTCs. We heated up the meter, and yeah, I definitely didn't like that. So this particular meter I know uses gas discharge tubes on the front end, so that's probably not a problem. We could hook this up to a power amplifier and see if we can get 100 megahertz out of it. Alright, so our little terminator is fairly limited how much power we can put out. As you can see, I just have our larger attenuator attached. Of course, this is terminated on the back side, so this is essentially a wideband 50 ohm load right now. And you can see, even at these higher power levels, it's still reading like 80 megahertz, and currently we're putting out 31. And this is at quite a bit more power. You can see we're still reading 79 megahertz. And there's no sweet spot. You can see as I bring the power level down, it's reading 3.5. And as I just start turning this thing up a little bit, see it snaps right to 62, 76. Now again, right now, I've just got this short chunk of coax connecting down to our terminator. And then no terminator at the scope. Of course, the front end of this is going to be a mega ohm or so. You can see the reflection isn't really causing any kind of a problem with this. But again, we take that signal. Let's just do that. We'll go right from the scope here and go right to the meter. And you can see it's reading 79 megahertz. Yeah, I don't know. To me, it looks like the meter just maybe can't read up to that 100 megahertz. Certainly not reliably. Off to my left, you can see I have our high voltage power supply out. Both meters are attached to the output of the power supply. You can see we're currently putting out about 1.9 volts or so. 2 meters reading fairly close. Let's go ahead and turn this up a little bit. Looks like at 30 volts, the high voltage indicator comes on. Here we are at about 418. Again, both meters reading fairly close to one another. Let's go to the high range. And it's about the limit of the power supply right there, so about 1,000 volts. Again, you can see both meters are fairly close with one another. Alright, I've restrapped our power supply to put out an AC voltage. Let's go ahead and turn it on, and you can see we're putting out roughly 132 volts. Let's just change this to AC plus DC, and you can see it's about 543 volts. Again, let's look at the AC waveform, and you can see about 526 volts AC. Let's look at the frequency. It should be 60 hertz, and that's what you get. Alright, so that's not a real intuitive setup. So once you place the meter into the frequency mode, how do you get it out of it? If we select hold and turn it back off, nope. If I hold it for a long time, nope. Maybe select the range, nope. Null, nope. Huh. So it looks like the only way to get this thing to clear out is to go off the function and then return. Huh. Not a real clean setup, I guess. Alright, so let's just see how this behaves now. We'll go back to DC volts. Looks good. A lot of meters have an issue with this. Even the Brahmin on the right had a few problems with this type of a waveform. And there's negative 126. Let's go the other way. Looks good. And let's go to AC plus DC. And again, we'll do the same thing with the Brahmin. And let's go ahead and change our bias. And let's try going the other way. Looks good. And let's select the AC voltage mode. You know, I don't understand. You've got this AC volt mode, and you can display AC volt mode here. Yeah. Of course, you get this low pass filter feature. I don't know. It's kind of a weird meter. Alright, let's go to AC volts. So 527 and 527. And again, we're going to add a DC bias to this. And basically no effect. Let's try it in AC volt mode. Looks good. Alright, no problem there. I think that's going to be it for this initial checkout video. If you own one of these meters and you're actually able to get the frequency counter to work up to 100 megahertz, do me a favor and leave a message in the comments, and I'll see if I can replicate whatever your setup is. Because as far as I'm concerned, it looks like this particular meter, that function doesn't work. Now that I know that the meter sort of works, we'll do some kind of a comparison against some of the other meters. So stay tuned for that.